Hi guys and girls, in this video I will tell you about areography as a science. Areography, a branch of planetology that studies the formations on the surface of Mars. The concept covers the definition of boundaries and characteristics of various regions of Mars. Areography works primarily with the fact that the Earth is defined by the term physical geography, that is, with the distribution and location of various physical features on the surface of Mars as well as their cartographic reflection. History. The first observations of the planet Mars were made from the Earth's surface with telescopes. The history of those observations can be traced to the opposition of Mars, when the planet is closest to Earth and therefore it is best seen. Such confrontations are repeated with a period of 779 days. Even more convenient for observations are the large confrontations that occur every 15-17 years, August-September, and differ from the usual confrontations in that Mars is currently close to the perihelion and therefore closer to Earth than normal. Due to the ratio significant eccentrically of the orbit of Mars, the distance to it in different confrontations can vary from 56 to 101 billion kilometers, year almost twice. In September 1877, the Italian astronomer Giovanni Schiaparelli published the first detailed map of Mars. On it he depicted many objects called canali, channels which, as it turned out later, were only optical illusions. Those canals, according to the astronomer, were long straight lines, so he probably gave them the names of famous terrestrial rivers. The name canal has been misinterpreted as channels, that is, artificial formations, and such an interpretation has led to long-running controversy over Martian channels. Based on the result of those observations, researchers have long believed that Mars has vast seas and vegetation, and it was only when the first spacecraft visited Mars during NASA-sponsored Mariner missions in the 1916s that those myths were finally dispelled. Several maps of Mars were created from data obtained during those missions, but full, highly detailed maps were created only after the mission of the Mars Global Surveyor, which was launched in 1996 and ended in late 2006. Those maps can be viewed online at www.google.com full stop, Mars. Topography. The dichotomy of Martian topography is amazing. The northern plains, leveled by frozen lava flows, contrast sharply with the southern hills, ripped with depressions, faults, and craters formed by ancient meteorites. The surface of Mars, which is visible from Earth, is divided into two types of territories, which differ in the meaning of albedo. Lighter plains covered with dust and sand rich in reddish iron oxides were once considered Martian continents, so they were given such names as Arabia or Amazonis, later derived from Arabia Terra, Arabian land, and Amazonis Planatia, Amazonia. Dark details were considered seas, hence the names Mare Erizerum, Mare Sirenum, and Aurora Sinus. The darkest part of the surface visible from Earth in Certus Major Planum. The shield volcano Olympus Mount Olympus rises 22 kilometers above the surrounding volcanic plains and is the largest of all knowledge mountains on all planets in the solar system. It is located in the Terraces volcanic region, which in addition has the largest canyon system in the solar system, called Valles Marineris, which is about 4,000 4 kilometers long and 7 kilometers deep. Mars is also dotted with many impact craters. The largest craters in Mars, as well as the entire solar system, are the Areotio and the Hellas Planitia and Utopia Planitia. See also a list of craters on Mars. Mars has two permanent polar ice caps. The north is located in Planum Boreum and the south in Planum Austral. The difference between the highest and lowest points on Mars is about 30 kilometers. By comparison, the difference between the highest and the lowest points on Earth is only 19 kilometers. Combined with the planet's excellent radius, all of this means that Mars is almost 3 times as raw as Eve. The details of the surface of Mars, as well as other celestial bodies, are dealt with by the Working Group on Planetary System Nomenclature of the International Astronomical Union. 0 height. On Earth, the height is counted from sea level. Since there are no oceans on Mars, and accordingly, sea level, another level of zero altitude or date, is required to map the surface. It is taken to be the aeroid, the potential surface of gravity, which includes gravitational force and centrifugal force associated with the rotation of the planet. However, there are an infinite number of such surfaces nested, and at different times the countdown was from two different aeroids. In Italy, since the Mariner 9 mission, the level of altitude for Mars has been determined by atmospheric pressure. The level of constant pressure in a calm atmosphere coin, uh, coin, coincides and with the equipotential surface of gravity. Zero was considered to be altitude where the pressure is 610 pascals. This value was taken for two reasons. It is close to the average for the surface of Mars and the minimum at which water can exist in a liquid state. Note that choosing this value does not mean that liquid water must exist at lower altitudes. It only means that it could theoretically exist there if the temperature exceeded zero. The references of altitudes to atmospheric pressure is bad because it changes during the year due to gas exchange of the atmosphere with polar capes, and this level varies by yeah, 1 or 2 kilometers. In 1999, data from the Mars Orbiter Laser Altimeter on the Mars Global Surveyor set a new level of altitude. It is an asteroid with an average equatorial radius of 3,396 kilometers, which is equal to the average equatorial radius of the planet with an accuracy of several hundred meters. The new level is higher than the previous one. During the vernal equinox for the northern hemisphere, it corresponds to a pressure of 5 MB megabar and lies 1 kilometers above the level of 6 megabar. The deviation of this area from the ellipsoid of rotation reached 2 kilometers. In particular, it rises in the area of large mountains, which led to a decrease in their measured relative to it. Sometimes other levels of altitude are used for Mars. An ellipsoid with an equatorial radius of 3,396 kilometers and a polar one of 3,376 kilometers, as well as a sphere with a radius of 3,396 kilometers. Mars is the only planet for which there is a global relief model with an accuracy of altitude of the order of meters. Zero meridian. The location of the Martian equator is determined by the rotation of the planet, while the location of the zero meridian was chosen as for the Earth at any point on the surface. Subsequently, its position was adopted by subsequent researchers and came into use. German astronomers Wilhelm Becher and Johann Heinrich von Mädler, when creating the first systematic drawing of details of the Martian surface in 1813, chose a small round object as a starting point. In 1877, their choice was borrowed and used as a zero meridian point by Italian astronomer Giovanni Schiaparelli when he began work on his famous maps of Mars. After the 1972 Mariner 9 spacecraft provided the scientists with a significant number of images of Mars. Merton Davis of R&D Corporation chose a small crater, later named Area Zero, located in the sinus meridian, Middle Bay or Meridian Bay, on the Becher and Mädler lines to provide clearer territorial definition of longitude 00 when creating a planetographic geodetic network. Martian dictonomy. Researchers of Martian topography must pay attention to the dichotomy between the northern and southern hemispheres of the planet. Most of the northern hemisphere is relatively flat with a small number of impact craters and is located below the conventional level of zero height. Unlike the northern hemisphere, the southern hemisphere will be filled with mountains and hills, mostly much higher than this level. The difference in the average height of the surface of the hemispheres in 1 or 3 kilometers. The boundary that separates them is of considerable interest to geologists. One of the most distinctive features here is the meager land. This type of relief is formed by table mountains, hills, and flat bottomed valleys with walls 1 kilometer height. Shovel-like talus plumes can be seen around many table mountains and bills, which have been found to be actually glaciers hidden under a layer of rock. Other interesting features of the terrain are river valleys and outflow channels carved into the surface. The area of the northern lowlands is about 1/3 of the entire surface of Mars. This low section is relatively flat with scattered impact craters. The other 2/3 of the Martian surface is occupied by the southern hills. The difference in height between those two hemispheres is incredible given the density of meteorite. Greater scientists believe that the southern hemisphere is much older than the northern plains. Much of the heavily cratered northern hills date back to the period of heavy bombardment of the solar system from the Noah era. Various hypotheses have been made to explain those differences. The three that are considered to be the closest to the truth are the only extremely large-scale collision with a cosmic body, several smaller collisions, and endogenous processes such as mantle convection. Both hypotheses concerning collisions with space bodies affect processes that may have taken place before the end of the primordial bombing period, and this suggests that the dichotomy of the planet's crust has its roots in the early history of Mars. The hypothesis of an extremely destructive collision with a very large cosmic body first voiced in the early 1918 was initially received with skepticism given the elongated shape of the hypothetical trail of collision. However, a study conducted in two 2008 helped to gather additional data that are fully consistent with the theory of a single giant collision. Using geological data, researchers were able to obtain information that confirms that Mars once had a collision with a very large cosmic body that collided with the planet at an angle of about 45 degrees. Additional evidence that could definitely definitely confirm the truth of the giant collision theory can be obtained from analysis of the chemical composition of Martian rocks, which should show signs of post-shock rise of mantle matter. That is all. Thank you for watching. Goodbye.